All right, in this first problem, we're looking at a reflected beam off of a surface, bounces off and redirects over towards this wall. We'd like to know what the initial angle is, and what we do know is where it hits on the wall, so we know from the point of contact in the x direction and in the y direction. And so the key here is realizing that this angle, by the law of reflection, is equal to this angle, and then by geometry, this angle is the same as this angle. So this angle here is the angle between this line and vertical, and then this angle here is also the angle between this line and the vertical. So they have to be the same angle. So then we look at this triangle and say we have opposite and adjacent. That's the tangent. Tan theta is this number, whatever you have for this number, over this number, and then you solve arctangent to get the angle that you need. Okay, so that's the first question on the homework assignment. The second question I received is actually for question 6, and that has a beam. It says a white beam. I don't know why I made it yellow. A white beam that's coming from glass and then refracting out into the air. So it's going from the glass index of refraction to the air index of refraction. And different colors of light actually have slightly different indices of refraction, and that's how a prism works, actually. So you've probably all seen glass prisms. You put them by your window and you can get rainbow patterns. Well, that's because the different colors refract at slightly different angles through the glass. So when they bend out into the air, the colors spread out and you can see the rainbow. And the white sunlight contains all of those colors. So if they're coming from glass all at the same angle, so the beam originates in glass, and we're given what that starting angle is, then we can use Snell's law, the law of refraction, to calculate the angle of each beam and find the difference between those angles. So what the problem's actually asking for is the angle in here, in between the red and the violet beam. So we do Snell's law twice. In the first case, we have, this is, I think, this is the red index of refraction, and this is the violet index of refraction. The n over here is air, which is just 1. So going out to 4 significant figures, the index of refraction of air is still just 1, basically. So we can calculate what the angle is for red and the angle is for violet in both of these cases. Take the difference between them and you get the angle of separation of those two colors from red to violet. Okay, which is essentially the full spectrum, right? So from red to violet, all the colors in between, so red, orange, yellow, green, blue, they're all in between here. And so if you put a piece of paper right here, you would see the rainbow pattern of colors.